thing. Yeah, let's do it now. Okay. So in the last class, we were talking about a small scenario. I told that today we will quickly just recap that and then jump to the next topic. We are talking about, right, static and our class variables and static methods are class methods. So that is the topic which we were discussing right now. So this is what I was talking in the last class. Somewhere there was an error where it didn't work for me in the last class. But this is something which we are implementing in our automations. So this is how we have to define a variable as a global variable. You should define that, use the global variable and that database name. And then what is that we can do? We can just initialize that variable with some value, that whatever the URL you want to assign, that URL you have to put assign to database. And then that you can use anywhere. You can see now I declared a method M1. In this method M1, I am calling database directly because it acts as a global variable. Similarly, we can do one thing. We can try to call database here also. Let me do one thing. So df some test. Okay. Sorry. Some test. And then maybe we can take a parameter as db. Okay. And then print db plus connected something. So while calling this class method, we do one thing. Let's try to call test method. So here, all test dot, sorry, what is this here? Test one dot test, and to this pass this database name. Because this takes a parameter, what does it print? Database. So you can see here, we are declaring global variable. Likewise, you can create many global variables and then you can consume these global variables wherever we want. You can see here. So without any this thing, I believe you don't need to pass. Let me do one thing. Let me try using it data directly. Database name. It's just database. It's not name. So we can remove this. Somewhere you can see this got imported. That is not right. So you have to just say, what is it? Database. Let's run this prints. And here we are consuming the database directly. Right click, run this. Okay. Test has some issue. Okay. Okay. Takes one positional parameter, but two were given. I got it. This I should remove here. No problem. Let's run this quickly and test it. Now you can see test connected. So this is what I want to show in the last class, friends. So what is that? Apart from what is it using globals method, right? So how it impacts. We'll take one more small scenario for that as well, and then show you that difference. But this is the idea. Now you got it right. How to define a global variable, how to consume it without declaring again. Suppose you see here in this method inside a class, I am using database name, that variable, global variable, without declaring it again or passing it as a parameter. Similarly, you can see M1. Even inside M1, this method, I am directly using database because database is set as a global variable. I just broke down my program into main like this so that this main acts as a driver for me, and I'm trying to call it by adding this test. I mean driver test here. Validation. If it is main, I should call main, something like that. This kind of breaking down makes more add more sense to the code hygiene, friends. So this is overall idea. Maybe what I just want to show you is one more quick scenario, and then jump to the class methods and static methods. These are simple things. We don't need much time. Or else I'll take it up at the end of this session. Much more difference between local and global variables. Now, this is the scenario we were talking in the last class, right? We had discussed about the importance of objects, how objects are created, difference between static variables and instance variables. All that we had discussed in the last. Sorry, friends, I was having little caught up with cold. Still, I couldn't recover. And meanwhile, in the middle, if anything is just, I'll just mute and just come back quickly. That's all. Now, what is it? Static methods. This is a simple one, friends. So these are static methods you can see here. This is how you define a static method. In the last class, we have defined a method to increment static variable. This one somewhere we had it. So where is that static tester? Let's just use this, not this one. Did I remove or what? Oh, I should not remove. Sorry. Yeah, let me share this with you. This might be helpful for you to break down your program, how to break down, how to add a little. Let me just share this. How to add a bit of hygiene to the code, all that. This helps us. Still, we can improvise it, but just now after this, what else we have? I would like to, there is an increment method here. You can see this, right? There was a scenario where we tried this. Let me just do one thing. Otherwise, I'll take a new file so that it's easy for us. Python file, static underscore test.py. Okay, we don't need to say .py. Oh, sorry. It might be there already. I'll just give another name. New Python file, static underscore. Okay, some anything should be fine. Test2, let that be there. Now you take one class, some test. Okay, colon. You can give any name, friends. It's not like it should be test always. You can provide any meaningful name. That should be fine. Right? So now, what is the point here? Let's declare a static variable. You know, right, how to define it. Just simply say some a equal to 10. That is a static variable. Inside class, outside any method. Otherwise, by default, whatever variables we declare inside a class, not inside a method, are static or class variables. We had a clear description, or we have had a very detailed discussion on all that, on all these things in the last class. Now you define one method, def incr. Okay, this is just a normal method. You can either use normal or you can use instance. Now I want to increment static method. I say test dot a equal to test dot. This is how you should call static method. Don't directly say a equal to a plus 1. Even if you want to try that, I doubt that works. A equal to a plus 1. This approach don't work because if we should access a static variable inside what, friends? Normal instance method. We can't directly access that. You can see if you try that, you can have an error already here. Okay, unresolved reference A. Suppose you comment this. Let me just show you. This is also one more important point to remember. So create object for this one. Yeah, definitely to call test equal to, okay, test, and then you can say test.incr. When I run this, let's run this now. You got an error, unbound local variable, because this just acts as a local, not as a static variable. If you want A to be a static, then call that A in a static way. How is that? Test dot A equal to test dot A plus 1. Okay, friends. So that's how you should do, friends. So this works now. Earlier, if I directly call A, it is behaving like a local variable. It is working like a local variable. But if you want static to be called, then you should call it using class name within instance method. Now run this. So it got incremented. Only thing is we should print that. That's all. I'll give you how to print a test.ta. Okay, this scenario we discussed yesterday. Right click, run this. Okay, and here we are accessing static member from instance scope. From instance scope. Suppose friends, I want to make this as a static method. Simple, very simple. Instead of using this as instance, make it as a static method. Simply we have to use add the rate and then we have to say static method. Simple. This is an annotation and this is how you should define static method in Python. Okay, add the rate static method on top of method wherever you want to make a method static. And this makes the method under that as a static one. Okay, so now there is a difference here. Earlier you can remove this. This self is not anymore required. You can see that. So now this is not an instance method. In fact, this is a static method, and this is not part of object. Now this is not needed. You don't need to call increment through object, but you can directly say test.incr. By using class itself, you can call incr. But if it is instance method, we must call that using object. First, we should create object and then we should call that instance method. But for static method, we don't need that, friends. Now run this. Let's run this. See, you got 11. And this is what? This is not part of object. This is part of class. You got it right. This is a static method. What is a static method? A static method is a method which is declared with this annotation static method, at the rate static method. Okay. And generally, friends, static method, why do we need static methods if someone asks this question, right? Because I am very sure how to use it, where to use it, when to use it. So if you want to build, generally, I'm just giving you the usage of static methods. Static methods are used in cases where you want to build utility methods. What methods? Utility methods. Suppose you take the example of math class. What class? Math module. In that math module, there are methods like sqrt, or there are methods like pi, are variables like pi, or methods like power. So many methods are there. And mostly these methods are utility methods. Utilities means what? They do some specific mathematical operations. Such variables, such methods you can remove, right? Because it's not a method, right? Such variables, such methods are utility methods. Okay, and usually these kind of utility methods we implement with what, friends? We implement as static methods. You got it right. So that is the idea. So anywhere, if you want to build any utility methods, like for example, you talk about list class, there is a method sort right inside that. So all those are utility methods. Sort is utility, or some kind of methods which perform some validations. or utility methods. I don't know if there is a reverse method in that. Even if reverse is there, such method is also utility. So this is the idea. So if you ask me a question when to static methods, this is the idea. And this is how we create static methods. Likewise, you can create, what is it, friends? You can define how many, you can call this method how many ever times you want. So test dot increment, right click run this. C12. Again, test dot increment, right click run this. See 11, 12, 13. So this is the idea about static methods, friends. Okay, got it right. What is a static method? Simply speaking, so now somewhere we have this is static variable definition. I'll just go to the static. Yeah, this is the definition here. So what is it here? We can access a few important points. Of course, this is how you should define a static method that we discussed now. Next step, we can access static variable from instance method directly. Okay, that is fine. We are seeing that example. Some like the example before that, maybe this one you can see here. So you can directly call a static variable from instance method. If you make this as static here, suppose you say some x equal to 10, and you can say test.x. This is what it is saying. We can access instance variables directly from a static variable. This is a static variable from instance methods, right? Next. Then what is static method now? Now you can see here. Static method is a method which allows to access only static members. Means variables are method directly, but if you want to access an instance member or variable or a function from a static method or a function, then we should create an object of a class in a static method. And we must access the instance members using reference of object or object itself. I don't think maybe this is a bit confusing for many of you. Let's do one thing. Let's do a simple example and let us understand it better. So simple points are simple, friends. So what is that? Then also few more important points. We can access static members directly in a static method. But if we should access instance members in a static method, then we should do that by creating object. What is this? How do we do this? Let us do everything with practical example so that you don't have any confusion on this. We can access instance and static members directly in instance methods. So I hope this should be very clear. So point is very clear. Inside instance method, we can have access to instance members or static members directly. But inside a static method, we can directly access static members, but not instance members. For that, if we should do, then we need to create object. That is the difference. My statement should make you very clear. I'm very sure on that. Okay, fine. Let us test these scenarios. Okay, let us take what is this. If you want to, we can use the same example, or we can take another example. Anything should be fine, right? So we'll do one thing: static versus instance. Static versus instance. Just add a quick program class, some test. Okay, and just take a variable a equal to 10 and define one instance method. Some what is that? Some m1, and just define a variable. So self dot some x equal to some 100. Okay, now this you can see now we have declared a static variable a and instance variable x. Fine. Now declare one static method def. So now something like you can just name it as some f1 function, static function. You remove this self. On top of that, if I want to make this static, what is that I should do? Apply annotation, and then inside this You can access static members directly. Suppose you can say test.a equal to test.a plus 1. Or you can directly print it. This is just testing, right? You don't need to increment. You can directly say test.a. Suppose if I should access x here. So suppose you see print, I cannot say, of course, self here. Self dot don't work. If self is not allowed, if we can't use self, then we can't have access to this instance variable. See, point is simple. If we want to access any instance member, variable or a method, we can do that only by using self keyword within a class. If it is within class, always we should use self keyword. If it is outside, we have to use object. Suppose inside this, I can use self and do something. Here, this static method don't have any self setup. Then how to call this x in this static method? Then the only way is a simple approach is by creating a object. What is that? Something like test equal to test. Okay, now I can print this x from instance variable x test dot x from m1. Now it's possible. So this is what we are saying. Static method, in a static method, we can access static member directly. If it is instance member, it can be variable or method. We can access them only by creating object like this object. Okay, so now you can see here. I say test.x, then this works now. Now what do you do? Finally, you create what is simple. Call this f1. But if you are calling f1 before that, m1 should be called if this x must be initialized. Okay, do one thing now. First, create object test test and then call this instance method so that it initializes x and this variable is stored inside object test. Okay, first make it ready so that f1 can have a smooth access to this x without issues. Okay, then what do you do? Next thing, test dot m1. Okay, this is fine. When you do this, it initializes x in this test object. Okay, now after that, you can directly say test dot f1 as, sorry friends, as f is, as x is already available, now you are calling f1. This will work for us. Let's right click run this. So attribute error, still we are seeing we already initialized, right?
In row number 15, small test, I guess, Manora.
Sorry?
Small t. In row number 50, small t, I guess, right?
No.
Yeah.
This is a static method, right? So we can call it
No.
directly using,
Oh, class. Okay.
yeah. So we can just quickly check it. What went missing? This is we are doing it in a right way. I'm not seeing name, but whoever it is, sir. Okay. We are doing it in a right way because this is a static method, right? See, very clear point. Static members are not part of object. We can call them directly using class name, friends. No need of any objects. So this is fine. This is okay, sir. This works. But somewhere it is maybe the scope is missing, probably. What it is saying is the test object has no attribute x. We called m1, right? When you call m1, it should exist generally. So we do one thing. Let's say test.print test.x. Here at this level, it should be available. Okay, I got it. Because this is a local object, right? So means local means this is created then and there itself. Probably. So this is a kind of global. That should be the issue. I'll just fix it up. No problem. I'll fix it up, friends. Not a deal. Okay. I'll make sure that X is accessible. As it is a local, by the time we are calling F1, this probably this is dying or something. I'll just check and fix this issue. Now let's See here you can see x is available till this. Let's do this. Run. Somewhere you can see here. So you are able to see, means see here, right? It is printing.
Sir, maybe we should use different names instead of test.
No. Test is fine. We don't have a big problem because there is a clear difference between this. This is a class with uppercase. You can see that, right? We are making it clearly different. We are differentiating without any conflict, whoever it is, sir. Okay. So we don't have issue there. Probably the issue is this. I'll do one thing. I'll fix this. So here, instead of creating a local object, probably I need to explain two things because one is about the heap as well as the behavior of stack. Okay, still even that is in the class scopes, you should get it somewhere. It's throwing test.x. Yeah, we are calling it test object is created. Then this definitely. Okay, the issue is this, friends. I got it now. Finally, I fixed this. You know why we are getting this error? Anyone? Not all that what we discussed so far. I am missing something.
We need to include self.x.
No, ma'am. No.
You need to include that
We
self
missed a
dot one, right?
small cut. Yeah, that is
Yeah.
important. See, even you create object here. At this stage, it is empty object, right? All of us know this with the postmortem we did in the last couple of classes. Then, if it is empty, if I directly call x on empty, test.x on empty object, how can we are able to call x? Then if we should call x, before that, what is that we should do? We should call m1, no matter if it is within method or outside method, wherever it is. So I should say first test.m1. This initializes x. This is missing, friends. That's why I'm getting this error. Now you see, you call just you don't need to call m1 now. That pre-initialization happened in the static method itself. Now you can this works, right? Run this now. See 10 and 100. Interesting, right? Finally, are you able to get the expected output?
Yes.
So see what the missing is. See, always remember, friends, if you are working with instance variables, make sure wherever you create object, immediately after that you initialize object if you want to access variables of that object in that scope. That is important. To initialize object, always you should call that initialization method. This is initialization method. Wherever you define that variables and initialize, that is actually pre-initialization method. Okay, anyhow, we are going to change that approach. We are going to introduce constructors in Python, how we use that, all that. But for time being, I am using a normal method. Got it right, friends? So this is the idea about, there is a lot of learning in this method, in this program. What is it? Suppose if it is a instance method, okay, just a quick wrap up. Okay, instance method. I'm just making it so very fast and simple. Okay, simple and fast. Instance method can access both instance members, either a variable or method, plus static members directly. You don't need objects, we don't need any other thing. Members directly. Opposite. Static methods. What is it, friends? So another example, static method. What is static method? If it is static, we can access static members directly. Static means variables or methods, friends. Static methods directly. And instance members, how do we do that? Now you see here. We can access instance members, but we use an indirect approach. But we should create object and then initialize that object and then call that members whatever you want. That is important. So we can access static members, static method members directly. Members can be both variable and method, and instance members through object. Simple. So these are important observations through object. So that's all, friends. So this is the idea. Now, if you want to add one more method, just a regular static method. Suppose you do one thing, define one more, something like some F2. Okay, make it as a static method at the rate static and remove this self. Okay, because and just use a simple quick print. Don't do anything. Just this is the okay test. Okay, and then just you can print F2. Now, see here, friends. Now you can call static methods, just not static variable, also a static method from another static method directly. Suppose you see here F2. You can call it, of course. If it is static method, we have to call it with that class name dot that method name. Now run this. You can see this. This is what I am saying. We can access static members from a static method with right directly. So what is that? You are able to call the static variable, the static method from the static method F1 directly. If it is instance method, suppose you have M1, or if it is instance variable X, how do you call it? First, you should create object, then you should call that instance method, then you should call that instance variable. This is an indirect approach. So that is what the point is. What is the point? A static method can have access to static variable members directly. It might be a variable or a method, whoever it is, static variable or static method. But instance members, we should access them through object. Remember this clearly. This is important, friends. Suppose you take one more instance method. You take one more instance method, df sum, okay, m2. Now let's call static variable in this. You can directly call without issue. You can just say print. You can directly say test.a, a direct access to static variable. And we have a static method here, right? So here also we can directly call test.f2. F1 or F2, whatever it is. I'm calling F2 because this is a test method. And I can access to instance members. Suppose I want to call M1, I can simply say self.m1. And after that, I can say print self.x. So you can see here, if it is instance method can have access to both static members. Okay, these are static, and instance members directly inside instance method. That members can be method or variable. It can be anything, friends. Right click, run this now. See, we got output altogether. Got it, right? So that is the, sorry, I didn't call M2, of course. What did I do? I didn't do create object now. So do one thing. You can just say test equal to test. And then you can say test dot M2. We are proving all that points here, friends. Now right click. You can see here, friends. Now run this so that whatever you have inside M2, you can see the output of that as well. Apart from what you have from a static method F1. Right click, run this. So you can see output from both M2, also from F1. M2 is calling what? Static method, you can see here. The static variable A, which is 10. And static method, which is this one. And then self.m1, it just call that. And then it prints x, is which is nothing but 100, we got it. Again, we are calling static method F1. What F1 is doing, calling test.a first, okay? After initializing M1, all that, okay? So that gives what? Again, that gives 10. After that, this prints 100. And after that, calling F2, which prints this. So this should give a clear idea, clear cut picture about differences between static methods and instance methods. Again, I have a question. So maybe possible. Please answer in the chat box or try to answer with unmuting yourself. The question is when to use static member instance methods, okay, and when to use static methods. So this is the question for you friends. We don't use static methods every time we do coding. There are certain places where we use static methods. So this is the question. When and what exactly is purpose of instance methods and what exactly is purpose of static methods? So anyone can answer, please answer it. I just try to make a quick answer. Instance methods means simple, as name says, right? Whenever you have object and on that you have, if you want to do any operations, like initialization is one thing. Okay, second thing, initialization. Second thing, if you want to do any operation on object or object data, object or object data, you know, right? Object is nothing but a small data pack. I have clearly mentioned this when we do the postmortem of class and object, right? So if you want to do any validation, any manipulation on object data, then instance methods are recommended. So simply speaking, any operation on objects, you generally what is that we do on objects is done through instance methods. Okay, instance methods. And when we talk about static methods generally, they don't have direct access to objects like how instance methods have. So what exactly, where exactly we use static methods? If you are implementing utility methods, if we should implement some mathematical methods, some kind of sorting, some kind of searching, some kind of all this kind of utility methods, right? If we should implement, simply speaking, some kind of mathematical or sorting or searching, some kind of algorithms. Generally, technically, we call them as utility methods. To implement such utility methods, we definitely need static methods. We don't use this instance methods for that. Okay, that's the idea, friends. So finally, you should get a clear idea about static variables, static methods. Okay, instance variables, instance methods, all that. Okay, next after that, static variable converted to instance scope. We can keep it as a last scenario. Okay, so this anyhow not really important now, so we don't need this scenario, but anyhow you can see here. See, if you want to convert static variable into instance scope, you declare a variable like this, and then you are saying that simply t1 dot a equal to, where is that, t1 dot a plus a. Okay, this one. We do one thing, let's run it. You get some idea how to convert, simply how to convert a static variable into a instance scope, means into object. This is another maybe useful, but now I don't think we really use it every time. Right? You created a class, you created a static method, and you created objects here, two objects you can see. And with this reference, you are directly calling reference here, probably, but I doubt if this work. Let me test it first, okay? So that I'll explain. Right click, run this new. So convert static into instance. Okay, just take this code simply just for testing. Yeah, you can see here there is some issue. I will fix it, not a big deal. Okay, so now you call this, then what you are doing, You are also calling these methods. So this we did already. So T2 dot A. Here A is a static variable, right? See, what is it? It is a static variable, right? So how do you call generally with class name? Observe this carefully. How do you call static variable with class name? This it should be test.a, but we are saying t1.a using reference. Of course, do one thing. So to this method, pass this reference of that class itself, t1. It's not directly working here. It's showing some error. Okay, let's remove it and see. Okay, let's run it directly. So we created objects here and implemented this. And if you see here, inside T1, we are saying T1 dot A equal to T1 dot A plus 1. Means what? A is a static variable. Now when you do this operation, this becomes instance. Similarly, same thing we are doing F2. What is that? We are adding A to object T2 by saying T2 dot A equal to T2 dot A something plus 2. Of course, leave about that plus 2 or something. You don't always need to increment by 1 or by 2. But the idea is here, we are converting, this is in a static scope. We are moving it to instance scope by doing something here, by taking that on reference directly. Now run this once. See, it's working probably. Now you can understand one thing. When I say T1 means it directly works on this object. It should actually, because when you are saying reference dot, so this T1 is nothing but which one? This one. Suppose you do one thing. If you don't create objects, comment these two. You can see immediately, we can see we got an error. See, we got error. Means what? This is a proof that this T1, whatever we are accessing directly inside class is nothing but this one, this object. So uncomment it. First, uncomment this. So what is happening here is, let me just prove all this. This is a static variable which is in a class scope. What scope? It is in a class scope. These are all, see, friends, if you think this will be useful to you, use it, friends. But I am going beyond our this thing. We are going too deep into the concept of this classes and objects. Okay. And these are really useful for you. No doubt about this. Okay. Now understand this. This is in static scope. When you call this on, this is instance, right? T1 is object, T2 is object. You are calling A on instance T1 dot A equal to T1 dot A plus 1. Means what? It gets definitely converted to object scope and you print T1 dot A, it prints A. Similarly, same thing here. T2 dot A. Again, we are calling object 2 and assigning something to object 2 here and printing it. Okay. Meanwhile, I would also do one thing. Print T1 dot X. Sorry, T1 dot A. I'm directly calling A from here and see what will be there here. T1 dot, again T2 dot A. So as per this, if I say that T1 dot A, 10 plus 1, it should be 11. T2 dot A, 10 plus 2, it should be 12. And these two must be assigned to this object T1 and T2. Then T1, when I call T1 dot here, again I should get 11 and 12 here. Let's test it once. That is the idea. Perfect, right? See, got it. So finally, the point is, what is the point? Earlier, this is in class scope. Now you have moved that to instance scope. See, I am able to call A from objects directly. Means what? Simply speaking, this is in converted to instance scope as well. So this is another important point. to be noted, friends. Understood? This is a little deeper topic, but definitely useful for you if you want that memory level understanding of class and object. Okay, that static methods, all that stuff. Okay, I'm just sharing this as well. And this code is converting static to instance code. Mostly we don't need this scenario, right? But this is for your information, FYI. That's all. Next, I should also share one more example. This one, right? Yeah, I doubt if I share this. Insert this. Okay. Did I miss anything here, friends? Just let me know if I miss anything. One more example is this, I believe. Let me share this as well. Okay. I think we did covered everything. Yeah. Next topic. Let's move to the next scenario. Class method. Now we had discussed static methods, right? Another similar thing, another method like static is class method with a slight difference. We'll see that with practical proof and examples. Okay. What is a class method? Simply see, it is similar to static function, but declared using decorator at the rate class method. Simple. See in this program, if you see, sorry friends, in this method you can see, how do we define static methods using this annotation? Suppose if you come to class methods, we just change that annotation. Of course, both of them is almost same. They act at class level, not at object level. Got it right? What do? They act at class level, right? Scope. The scope is class level for this. So the class method is declared with parameters here. Only difference is if it is static, we don't pass any parameter. See here. If it is a class, we should pass, like self for class, we should pass CLS. It is a built-in keyword. Okay, what is that we use? CLS, which says it is a class, which by default implicitly holds that class information, that class name here. What it holds? Class name. We'll see that with examples. But you got it right? What is class method? Declared by using annotation at the rate class method. Now what do? Let's do one thing. Let's take one example so that you get the idea. Right click new. Okay. New scratch file. No, sorry. I should choose Python file. So class method. Okay, test something you give. Now you take an example of class, something like test again. You can take any name for class, friends. I'm just choosing test just to make you understand the scenario. Next one. You can declare a static variable 10 and then d of something like m1. Okay. You remove this and make it as a CLS. On top of that, use at the rate class method. And then inside this, you can say test dot a equal to test dot a plus one approach. Okay. Another approach, CLS dot A equal to CLS dot A plus 1. Yeah, sorry friends. See here, I did access this static variable in two ways. What are those two ways? The first approach is a static way. This second approach is through a class method approach by using class keyword. This is important. Observe carefully. So class method is similar to static method, which is used to do something on static members. Got it right? So it is also used to do something on static members. Difference is this static method can access static members only in a static way. But class method can access through this approach. That is difference between static and class. Now you do one thing, just do one thing. You just print test.a and then print cls.a. See, there is nothing confusion here, friends. It's very simple. Just understand it in a very simple thing. You know by now, with the number of repetitions we had, if it is static variable, we call it with class name anywhere in static method or instance method. Just saying class name dot that variable name, right? So, and if it is class method, if it is static variable, we can call them in static way. This is clear. It might be in static method or instance method or class method, any of these three methods. There is another way to call static variable through this class scope. What is that? cls.a. That CLS keyword is also working at class level scope, right? Any class members you can also have access through CLS, this CLS access or CLS keyword. Now run this. So we do one thing now. First, the way we call even class method is same as static method. So you don't need to create object for this. Test dot you can see here M1. See, because even class methods are not part of object, they are part of class. So you don't need to create object. When object is needed, when something is part of object. But both static methods and class methods belong to class, not object. So right click and run this now. You got output here. See, perfect. Right? So 12, 12 are. Why we are getting 12? We put A here. Then test.a equal to test.a plus 1. Okay, it should be 11, right?
Students, right, sir?
Okay. Yeah,
That's
I
right, sir.
got. I got it. Correct, correct. See, we did one incrementation here. Sorry, friends. One incrementation, it becomes 11 because this is static is a global variable, right? As discussed yesterday. And here it is becoming 12. After that, you say test.a. This global variable have latest incremented value, which is 12. That's why we are getting 12. If anyone have any doubt, just this explanation should suffice that doubt, friends. Okay, right click run this. So perfect. You can understand class method, right? This is the idea. Difference between class method and static, we have clearly made that differences in this simple example itself. Okay. So that's the idea. Let me share this code with you and finally conclude this. Conclude this. So now not this somewhere I put few one or two examples to demonstrate this. This is fine. I had already discussed all this stuff. Then tomorrow we talk about this one, friends. Constructors anyhow. But where did I put this? Put two examples just to quickly show you. Already we covered that difference. Not like we missed it. I put it somewhere. Last method. Okay, let's see this example. So see this example, actually, this one, see here. If it is static method, see here, friends. You can see the difference between, already we discussed this anyhow, but let us quickly summarize this. This is a class static method, two local variables, adding that and returning. This is a kind of utility. By now you should know when and where we should use static methods. Okay, if you want to implement some utility methods, then we apply static methods. Fine. Now you are calling it and we get some output 8. Fine. Next scenario, employee. This is also static variable, but we are applying class method. But what is that we are doing here? We are able to modify this variable at class level through what? Through this class method. See, because you are passing, you can see now here, this example. This is company name, right? Tech car. This should give you a clear idea. We are calling set company name with two parameters, class and name. And you are saying class name dot company name equal to sub. We are just assigning something here to this static variable. We'll do one thing now. So we'll test it one by one. This anyhow doesn't need much testing. This is straightforward. So that when we test it, you get more deeper idea. Okay. Static test 3. So this doesn't make, this is not really that difficult to understand. See, created static method, calling it in a static way using class name, just passing two parameters as static method has two parameters. Let's run this. This returns that addition result. So that is passed to print. Run now. We get 8. This is fine. Next one. You can, for time being, if you want, you can put that also. Now copy this. Use this. Code wise, we don't really have something difficult to understand. Employee, just one static variable, global variable at class level, not global variable at class level. Static acts as a global at class level. We are assigning this, and then sorry friends. Now you can see set company initializes this static variable with some local variable, right? Already we have something, but we are modifying that with this set company name. Okay, fine. Right? Using class method. That is fine. Now call this. This is approach 1. Test 1. What is that we are doing? We are calling this variable directly, right? This static variable from employee class before calling class method. Let's run this first. We'll go step by step. What is that? We got tech car. In the second scenario, you are modifying a class level variable through this approach. What is that? Class method. And class method have access to class level variables through this CLS. See there, through this CLS. Static methods don't have that direct access, that implicit access, but class methods have that. If you want to do some changes at class level without actually touching that class, then these class methods are really useful. Now, are we saying some employee dot or something? We are not doing anything. We are just using this keyword class and just saying company name equal to some name. So that is what the exact purpose of class method. So what is that? Point is, if you want to make some changes at class level without actually touching that class. So that should give you a clear picture. Now you can copy this set company and set it here, right? Now, what is that we are doing to this set company? We are passing one local value, InnoTech. Instead of tech car, we are changing that. And this class keyword, just make that update to this static variable by initializing this value, whatever local value we are passing to that. And after that, this variable get modified. Okay, now let me test. So now you call this again, print and put it here, run it again. Now you can see InnoTech. I'm doing same call as I did for static, but this time before that, between that, we did modified that static variable by using class method with a how in a class way, right? By using this class keyword, we are making change at class level using class method without actually touching that class name. So this is what we have advantage with class methods compared to static. Static methods don't have this kind of advantage. They don't have implicit access to class level members without using that class name. But class method has that thing there, friends. Got it right? That is the exact difference between static methods and class methods. In a way, you can have access to class through this implicit access to class members through CLS keyword with class methods. But for static method, always it has to be that class name dot something. That's how it has to be. So this is difference between class method and static method. If you want to if you want to see the difference, this is the difference, friends. Okay, let me share this with you. So let me, I think we are done with this, all these things, friends. Tomorrow we talk about, what is it, friends? We talk about constructors, that is init methods. Okay, you got it, friends. Okay, I hope you had a clear picture of each and everything. Still any doubts, let us know. We'll be help you with clarifying that with more different scenarios. Okay. Shall we stop here? Right. Thank you, friends. We'll catch back tomorrow again. Right.